Hi, everyone. Thank you very much for coming to my talk. This is Introduction to Wing, a new cloud-oriented programming language. And I will explain why we decided to go for a new language. And also, I would like to show you what we can unlock with it. Just letting you know that you can find these slides here. I will show this up again during the last slide, so don't feel rushed to take a picture. So I'm Cristian Pallarés. I've been a software engineer for more than 10 years already. I basically worked as a full-stack developer. So I've worked with PHP, JavaScript, TypeScript, Node.js, all that stuff. I've also contributed to open source a little bit. Nothing super important, but to Vue, the web framework, to Laravel, Progen, the CDK as well. And also I have some open source projects on my own, nothing too fancy though. And now I work at Winglang, which was founded last year in April 22 by Shai Bear and Elad Ben Israel. And if you know the AWS CDK, you may know that Elad was one of the creators of the CDK. And we mainly do open source. Every important thing, we do it through a request for comments, so it's open to anybody. And we have a very nice Slack community. There's many interesting people there, very passionate about what they're doing. And if you have any questions or you need any help when trying Wing, just don't hesitate to join and say hello. So in order to understand why we chose to create a new language, we need to understand the problems with the current technology stack. I've categorized frameworks and technology in different groups based on the developer experience that they provide. So first of all, we have CloudFormation and Terraform. And it's funny to me that they are labeled as infrastructure as code, but to me, they are more like infrastructure as config files. And maybe you see where the problem is, right? You have to write either a JSON file, or maybe you can use the Terraform language, but still they are kind of static files that they are maybe not meant for humans to use directly. They are better used with something on top of it. And this is why we have the CDK and the CDK for Terraform, which allows you to write your infrastructure using TypeScript. This is a big improvement in terms of developer experience. But there are still things that could be better. Let's see if we would like to create, for example, a function that puts files in a bucket. We need to do this, right? Pretty simple. We instantiate the function, we instantiate the bucket, but then you need to decide for an environment variable name to pass the bucket name to the Lambda function. Or was it the bucket URL? I will never remember which thing I need to pass to the handler. But anyway, the point is that you need to decide this name. And you are creating an implicit contract between your infrastructure code and your Lambda code, which is going to run. And this implicit contract, there's no compiler that will help you to keep this. This bucket name that I decided here needs to be used as well in my Lambda code. And for simple cases, it's OK. But imagine that you have two buckets, one for private files and one for public files. If you mix them up here, you're screwed. And the same applies for any kind of resource that you want to use in your Lambda. And also, you need to tell the CDK that you need your Lambda function to have permissions on the bucket to read and write. So later on, we have Pulumi. Not sure if you know it, but it has a similar syntax to the CDK. It allows you to create your infrastructure like this, right? But they have a very nice feature, which is the serialized function API, which allows you to write your Lambda code directly in your infrastructure code. And this is very interesting because we can get rid of the environment variables. We don't need to think about them anymore. We can just reference the bucket directly in the callback and use it. And this is very nice. But there is a catch. This serialized function API, it uses some features from the V8 engine, which is the JavaScript engine that Node.js and Chrome uses under the hood. And what it does is at runtime, it tries to get all the things that you're capturing inside your callback, in this case, the bucket name, and then renders a JavaScript function to be used for your Lambda function. But the problem is that this will fail in so many instances. It will throw an error depending on how you write your code and what things you're capturing. And I won't get into detail there, but in the end, the developer experience is not that great. So then we have very nice frameworks out there. We have SST, Eventual, Nitric. Recently, Amped got published. And you should try them out if you want to create a cloud application. They have very good developer experience, but there are still few things that could be better. Some of these frameworks are locked to AWS, which it may be OK for you, but there's more cloud providers. And it could be better, right? Some of the frameworks, or all of them, allow you to try your application locally, but still they require you sometimes to have an AWS account, because even if you work locally, some things are still deployed to the cloud. And some of these frameworks also require you to still write your permission policies manually, like in the example with the CDK. And at WingCloud, we were thinking that how can we fix all of this? Because on top of our heads, it can be done, right? And we got into the conclusion that we need a compiler to do all this stuff for us. So this is why we decided to create a new cloud-oriented programming language. So with Wing, we want you to be able to write your infrastructure and runtime code in the same language. We don't want you to think in environment variables, for example. Also, we want you to be able to try your application locally without internet access. We don't want you to have to use a cloud provider to do that, like the good old times. Also, as Elad likes to say, we want to democratize the cloud, which means we want you to be able to use any cloud provider easily. And we also want you to be able to deploy your application without changing any code to AWS or Azure or Google Cloud. And I'm a TypeScript developer, and every time I need to fix a problem, I think in TypeScript. And I'm the first one who is hesitant to learn a new language. So we thought it would be a common case, right? So we wanted it to feel familiar to other people as well. And I think the best way to see what Wing can do is to do some live coding. So we'll just open my VS Code there. And we will build some examples, and I will make them a little bit more complex until the point we see what we can really do. So I have my Wing file here. Yeah. So the first thing I will do is to bring cloud here. Yeah, it's pretty poetic, right? But under the hood, bring is like the import keyword in TypeScript. It allows me to get some modules into my code. And cloud is a native module from Wing, which exposes some cloud-agnostic primitives, like a function, right? So I can just create a new function here. And let's do a simple hello world. So this cloud function is cloud agnostic. Depending on the target I'm going to compile to, I can use it to deploy to AWS, to Azure, to Google Cloud, or any other cloud that we implement it to. So I will just compile it. I'm sorry, this is too big for me, but otherwise you won't be able to read it. So I will just compile the code. I'm going to specify the AWS Terraform target, and I will stick to it, but we have Azure as well and Google Cloud. but I only know AWS, so. Right. So what we have now is a target directory. Sorry, let me clean this up. We'll just compile again. So we have the target directory, and we can see that Wing created some files for us. It created the Terraform JSON here, which, well, you know, boring stuff, but, but we have our function here. And also we have the bucket necessary to deploy the Lambda function code. And we can find our generated JavaScript code with the. It's cool, right? But I can also wing it. Yeah, this is all Elad's stuff. He's pretty poetic. So what this will do is to create a local development server, which will watch our Wing file and reload every time I do any changes. But it will also open the Wing console. You can see it here, okay. Which allows us to visualize the infrastructure that we are creating, and also, more importantly, allows us to interact with it. So everything is running locally. I don't need internet access for this. And now I can invoke this function here, and we can see that it was successful, and we can see the log here. Also, we have a VS Code extension. So I can close this, and I can open the console directly into VS Code. Yeah, and the output instead will be logged here. So I can just invoke again. And here is the hello world. So now let's do something more complex. Let's do the same example as I showed with the CDK. Let's put some files in a bucket. But at this point, you may be wondering what the in-flight keyword is, right? So in Wing, we differentiate between two different phases, the pre-flight phase and the in-flight phase. The pre-flight phase is the code that runs during compilation. So it will run or on your machine once or on the CI, depending if you're using CI. And the in-flight phase is the code that runs on the cloud. So it's meant to be run on cloud functions. And we do this differentiation because it gives us superpowers. And we will see it right now. So if I was to interact with the bucket during pre-flight, I will see that I have some APIs, like I can add an object to the bucket during deployment, or maybe I can listen to some events, like when a file was created in the bucket, right? So I can do something like this. So this code will be called every time a new file is created in the bucket. All right, but what if I was to interact with the bucket during in-flight? What we will get is the in-flight API of the bucket, also known as the client of the bucket. So I can just go ahead and put a file in the bucket. So I'm going to, hello bucket, hello world. So I'm creating here a file named hello with the contents world. So now we can see two things, right? Because I'm listening to the bucket onCreate event, Wing is creating some infrastructure under the hood for us. It's creating a topic. Not sure if you can see it very well. And it's creating a function to manage this log. But this is not interesting for us right now, because what I want to show you is that now the console knows that our function is interacting with the bucket. And if I just try it, we can see that it was successful. Then we have our hello file with the contents world. Okay, now, if I compile it again, we can see, well, we have some files for the simulation, but these are not important to us. But our Terraform file, it will also have the bucket that we just created. But the interesting thing is that Wing have created list permission policies for our Lambda function. Sorry, it's very hard to navigate, but you can see here that our Lambda function has the permissions to put objects on the bucket. So that's something that we don't need to care anymore. Now, let's do something more complex. Let's say we want to build a resource that you can upload some files in it, and it processes them. Let's say we want to convert all the files that we upload here to uppercase, something simple, right? So in Wing, you can create your own resources like this. You can use a class. We'll name it file processor. And we will need a bucket to upload our files, obviously. And during construction, I will just create this new bucket. Now I can just instantiate this new resource that I created. So we can see now our file processor, which has a bucket inside of it, right? So now I would like the processor to be able to upload files. So let's just create a new function to interact with it. Now I'm missing some kind of API, right, to do something like put, like with the bucket. So we can just implement it like this. We can create a public in-flight function for a file processor, which will only be available during in-flight. So I will want to accept the name of the file and the contents of the file. And I can just proxy this to our bucket. So here we are effectively hiding that there's a bucket in the file processor by providing an API on top of it. So I can now put a file on my bucket again. If I invoke my function, again, we can see we have the hello file and the world content. OK, now let's do the processing. We want to convert the contents of the bucket to uppercase, and we will want to retrieve them later. So what I will do is to create a second bucket to store our processed files. Sorry. Now I need to give a different name to our bucket. This is a limitation that you might have found in the CDK. Every resource you create, you need to assign a unique identifier, unique inside the context where it lives. So I will just name it processed. And now, every time a file is put on a bucket, we can just use the onCreate event here. And we can do the file processing here. So first of all, I need to get the contents of the file that was just uploaded. And we can use the in-flight API of the bucket to do so. So we can do get. And this is already the string that contains the whole string. Now I can convert it to uppercase. And now I can put it on the processed bucket with the same name, but uppercase. So again, we can see again, Wing created the topic for us to handle the notifications. And if I invoke it, we can see that the previous bucket, it contains the original file, and the new bucket, it contains the file in uppercase. Now, imagine we want to hook into the processor, and every time a new file is processed, we want to do something with it. So we can use a preflight function instead. We can create, let's skip with the bucket's name. We can use an onCreate function here, and we want to receive a callback, which is going to be an inflight function that receives the name of the file that has just been created. And the only thing I need to do here is to use the onCreate event from our processed bucket. So I can do something like this. We'll receive the file name that was changed, and I will just call the callback. So now I can use this onCreate function in preflight. Sorry. And we can do something like file processed. Now let's see if I can show this up. Every time I save my code, the local simulation is restarted, so the state is not kept. So this is why I can just invoke it again. So we have the log, yes, here. File was processed. Hello. Cool. So, sorry. Now, things will get more interesting right now. Let's imagine our file processor. Let's imagine we don't want to stick to the bucket. Let's imagine we want to be able to work with any kind of storage. It doesn't matter what. Maybe I want to use a NoSQL table to store our files. What we can do with Wing, the same way we can create a class, we can create an interface. So let's create an interface for a storage. And we will use the same kind of API that the bucket has. So let's say our storage will have a put function, an inflight function to retrieve the contents of a file, and also we want to have the onCreate callback. Now I can stop depending on the bucket here, and I can just use the storage. We will pass the storage during construction of the file processor, so we can compose it. So let's do this. Bucket here, and processed here. And since the storage has the same API that we're using in the file processor, I don't need to change anything. Now, what I need is to implement a class that implements the storage interface. And we can do it just like this. Bucket storage implements storage. So we will have a bucket inside. I need to initialize it. And now I need to implement all these methods, which for the bucket, it will just as simple as proxying everything into it. So this bucket put here can return the bucket get, Here again, just proxying to the bucket. The key. So, done. I just need to create the new bucket storage here. I will give it a name. This is the one for the uploads, and the second one is for the processed files. So if we inspect everything, we can see that we have the file processor, and outside of it, we got the uploads and the processed classes. Sadly, we don't see the name bucket storage here. At some point, we will make it appear here. But we can see the buckets here. So if I were to try it, we will see that everything keeps working the same as before. And we have effectively composed and abstract the cloud with just code. This is something that it wasn't possible for me before. So now, let's imagine we want to use the table to store our files. Or even we could use a table for the uploads, or even for the processed, and mix them out. So I can just bring another package. The X module contains classes like a table, which are cloud agnostic as well. So we can just go again and implement another storage. And just to make it quicker, I will copy paste everything. But instead, I will just depend on a table here. I will create the table here. So in order to create a table, you need to pass the name of the table. You need to specify the primary key that will have the NoSQL table. And also you need to specify the columns that you will have. So we will have a key, which is going to hold the file name and the contents. Now, the table has an insert method. Oh, sorry, it's called bucket, but it's a table. So I can just insert a new column to the table, and I need to specify the JSON that will be on this table. In this case, I need to pass the key again and the contents again. To retrieve information from the table, we can use the get method, which will return a JSON. And we know it contains the key and the contents. So I will just get the contents from it, and I will need to cast it as a string. And finally, here I have a problem, because this table doesn't have any mechanism to notify me that there was a change, that a new row was created. But since we are using an abstraction, we're composing everything, we can use a topic here, which is like similar to a queue if you don't know what a topic is. But I will just instantiate our topic. And every time a new item was inserted to the table, we will deliver a new message on the topic. And we will deliver the file name that was changed. And then here, I can use the topic on message. So every time a new message is on the topic, I can just call my callback. So if I didn't make any mistakes, which can happen, I can just interchange the bucket for the table, as our storage mechanism. I will make it bigger. So instead of buckets, now we have our table here, which is empty. And if I try it, it was successful. We see the table with the original file and the table with the uppercase file. And everything works the same way. I can hook something into this file processor and do something on another part of my application. And I will wrap this up. But I hope you can see the power of this. Being able to compose and abstract the cloud this way is going to make development much, much easier. And we are so early. It's been only a year since we were funded, and there's lots of stuff we want to implement. I picture type generics. I picture the compiler knowing whenever a function is in flight or not, so we don't have to type it all the time. I picture having stopwatches in our VS Code and stop the execution of your local simulation when it reaches there, so you can inspect everything. We're still researching all the clouds to think of better resource abstractions. The console can be improved in many ways. This map view that you see, we can show how your data goes and flows through your application. We can show you the traces of everything that's happening on your simulation, and many, many more things. So this was Wing, and thank you very much.
Thank you, Cristian. I like the idea of saying to a product manager, I'm going to wing it into production. I think that's wicked. Any questions for Cristian? Okay, cool, great.
Thanks, Cristian, for the talk. It was my first time seeing Wings in action, and I thought that was a great introduction, so thank you very much for that. My question focuses on the automated generation of the permissions, specifically. So your example there had a function that was granted permission to put objects in a bucket. Mm-hmm. Let's say I'm in a situation where I only want permission for certain key prefixes, just one part of the bucket.
Yeah.
Can Wings do that yet? And if so,
not right now. We're still researching of a better way to explicitly give permissions to things. I think there's an RFC, but I'm not really sure right now. But yeah, that's still open to research.
No, that's great.
Yeah.
Cheers.
Cool. I saw a few other hands up. Yeah, come this way.
Hi. So I write a lot of Terraform, but I have used tools like Pulumi and some of the other examples. I quite like the idea of abstracting away the complexity. I saw a button on the map view about testing, so I'd be interested to hear a bit about, I don't want to put you on the spot and ask you to give an example, but yeah, I guess what testing functionality is in place?
Yeah. So did you see this section here, do you mean? Or?
Yep.
Yeah, so in Wing, I didn't get into that, but you can write tests. I'm not sure if I can do a test right now, but to be honest, I don't remember the syntax. I have never done testing Wing yet, so sorry about that. But the console can show you the tests, and it will also run them and show you the whether they were successful or not. And by default, we hide them from the map because they are not part of your infrastructure. But you can toggle this and see them. In fact, we also show your resources here, and also we show the tests here, but I don't have any. And you can see them here, and you can rerun them, etc.
Okay, great, thanks.
Thank you. A few more hands, yeah.
Hi. I've just wondered how near you would say this is to being like a production ready, whether it could be used in production or how far away that might be.
We're still at alpha, and we are dog fooding Wing by creating some services with it. So I think we are still a bit early. So before doing something for production, I would wait a little bit.
Yeah.
How
far away do you think you are from sort of a year or something like that?
I can tell. I don't really know. I mean, we can get stuff working right now, but maybe you find that something you need to do some workarounds to make it work for you. For example, we have had problems because we were trying to build a website with Vite and trying to interact with all resources from Wing from our website. It was hard, but we used this opportunity to think how to do that, right? How to integrate. So, yeah, I think not really yet, but I can tell how far is it. I don't think it's too far from it.
Okay.
But yeah.
Okay, then if I may, a quick follow-up question is just so how much depth of support is there at the moment for things like other resources like load balancers or IAM or you know, and so on?
Right now we have quite some basic primitives. We have functions, generic table. We have topics, queues. Recently, Tuf created the website resource, but we are missing long-running primitives like maybe something like a Fargate or something like that. That's still not ready yet.
Just on that, is there a website, a GitHub page where people can ask what they want to be prioritized as resources to be supported?
Sorry, can you repeat?
Is there a way that we, as a community, can prioritize what resources are prioritized for you to build?
Well, I mean, everything is open source, so maybe it's up to the community, right? If we listen to the community, if the community thinks a resource is more important, for sure we will work on that.
There was a few questions over here, right?
Hey, thank you very much. I had a question around what actually happens and what actually happens when it gets deployed, particularly with your last example of the table and then the thing off it. So in my head, if this is deployed to AWS and you've got a table, assuming it's Dynamo, and there's a Dynamo change stream coming off the back of that.
Sorry, I didn't quite get that.
If there's like a Dynamo, if that table's a Dynamo table, and you've got the event coming off of it, and it goes to a topic, you can't do Dynamo streams to topics, presumably SNS. So you're now deploying Lambda functions in between this to start piping this data around. And do you think there's a worry that deploying additional resources that aren't obvious to the end user, that you end up getting gaps in monitoring, alerting, and awareness of what you're actually running?
Right, so first of all, this table is cloud agnostic. So it will work on any cloud provider you use. In AWS, it will be a DynamoDB table, effectively. But also, if you want to go into more detail, if you know you will stick with AWS, you can use the DynamoDB table directly. In fact, you can install and bring from Wing any package that exposes CloudFormation classes. So you can go and use them directly. Right now, you can't use streams from the table, the cloud agnostic table. This needs some research to if we can make it work with other cloud providers directly. And I think if it doesn't work like that, maybe we could provide some abstraction on top of it and create more infrastructure for you directly, so you can enable streams. And I don't know the rest of the question.
So I guess like what actually happens? We've got like the notification when something gets added to the table, and if we're not using streams, how are we getting notified something's been added to the table?
Right. So here we're just instantiating a new topic, and we are leveraging it to do that. And since this table is hidden behind our storage implementation, you should then be able to insert any new data without going through this path function, which is calling the topic. This is not a perfect implementation because things may happen in between this, or maybe you insert the same column twice. But for that, we need to go for other kind of implementation, like the I don't remember quite the name right now. Yeah, I'm sorry, but what was the name for that? I don't remember. But yeah, this implementation is not perfect, but we can do it in a way that it always works like this, and we can make it act like streams in a way.
Thank you.
Yeah, let's go for it.
Sorry if we're going over time. I was wondering if you had any abstractions around environments and different behaviors. So to give an example, perhaps in the development environment, we would create a table from scratch and add all the columns. But in the production environment, we'd only want to add the new columns. We certainly wouldn't want to alter the data that's already present. And that's a big challenge people have with things like CloudFormation and other tools. Right. So I'm wondering, do you have a way of coping with that?
You can access environment variables in Wing. So if that's enough for you to do different things during deployment, maybe you can use it. Yeah.
Cool. We are slightly over time, but if everyone doesn't mind, there is one more question in the room. So.
Yeah, just going off what he said really, with the environment variables, is there also a way to implement things like workspaces, like we can in Terraform?
Web spaces?
Yeah, so certain environments within the workspace of Terraform, so you've got different environments set up there rather than just through environment variables, or would you only be able to do it through environment variables?
So you can create it with Terraform?
Yes, you can, yeah.
Then we can integrate it in Wing.
Okay, brilliant.
Yeah.
That's all, thank you.
Can we please clap way louder than they did over there?
Thank you.